Alright, so today we are tackling a multitude of chassis. For this video it's only going to be one, but somebody contacted me and said, hey, I've got a Neotec 2500 and a 2501, and they were asking me if I could take a look and see if I could get them working and get them going. I said, yeah, sure, why not? Send them in. So here they are, but for some reason there was a mystery third chassis in the box. I was only asked about a 2500 and a 2501, yet when I opened the box there was a third mystery chassis. So they all appear to be a Neotec, so I don't know, I haven't opened them up yet to figure out which ones are which, but we'll go ahead and do that. They also sent a complete full box of all the parts and pieces that they figured I might need. Again, see, there's only 2 cap kits in this box for 2500 and the 2501. Oh, 2515C. Oh, that may answer the question right there. Well, in the correspondence with this person, they didn't mention anything about a 2515C. So it's possible that we have a 2500, 2501, and a 2515C based off of this. That I didn't know that this was in here. I just opened it up to make sure that parts were in there, but I didn't notice that there was. I figured it was 2501 and 2500. But anyway, so okay, I guess we can answer that question right now. To the whole family of chassis here, and he sent what looks like color transistors, fuses, fuse holders. I'm probably not going to need any of this stuff. Filter caps, HOTs. I might need HOTs, of course. Looks like there's a bunch of parts in here. Voltage regulators, I think. There's a whole bunch of parts in here, it appears, that I probably won't need half of them. I'm probably only going to need cap kits and maybe HOTs, but we'll figure it out as we go along. I guess what we'll do is we'll grab just one at random, and the first one that I grab we'll do the work on first here. So let's just, this one, let's try that one. So we'll take these and set these aside, open them up later. That one, and set this one aside. Okay, and our first one here, whoa, 2515C. Look at that. Okay, well, easy enough. We'll start with that one. And the only information I have on these is that they don't work. I don't have anything other than that. You know, usually I'll get information about, well, it's just ticking, or it has a black screen, or you can hear it at high voltage, you can hear it running. There's any number of things that I normally get, but these are all, oh, well, I'm not going to be able to work on this because I don't have a remote board. They didn't send a remote board. Without a remote board, I can't even power it up. So that puts the end of that. We got a broken resistor bent over, and our bridge rectifier is somewhat bent over. But it's all a moot point because without a remote board, well, that answers that. Can't work on this one. It could be in the box, but I don't think so. Let me open up the box and take another look, but I don't think anything else was. I think the box was actually empty. Alright, yeah, the box is completely empty. Let's make sure it's not in here. Flybacks, cap kits, parts, it's not there. Another flyback, yep, not in here either. So I'm not going to be able to work on this 2515C unless he can send me the remote board. So I guess we'll have to set this back aside and not do this one just now. So let's do the 2501. Now I did open this up and make sure that this one has the remote board. Also the 2500 has a remote board. So it looks like the 2515C is the only one I'm not going to be able to work on unless he can get me the remote board, because I can't even power it up with a missing remote board. And I don't know if the 2500 has the same remote board as the 2515C, then I should be able to use it. But I don't know for sure. What's going on here? So this is the 2501, as we can see. And then also on the side here, 2501. So this is the medium res 25-inch Neotec. And how come we have, well, we got a broken vertical position. The pot's okay, but the cover part is missing. Everything else seems okay. Not sure why the video connector here is disconnected off the neck board. And the ground. It's odd. Alright, well, either way, so at least I want to step in the right direction by having this on here. Okay, well, let's get this all cleaned up and ready for work, and then we'll see how what we find here. Well, there seems to be a bit of confusion here. Sorry about this. I was under the impression that I was receiving a 2701 and a 2501. Well, it turns out that I actually got two 2501s and a 2515C, so I don't have a 2701. We can forget about that. So they sent two 2501s and a 2515C. And I've been able to confirm that the 2501 and the 2515C are identical when it comes to the remote board. They're pretty much identical across the board. For all intents and purposes, the chassis are absolutely completely identical. And I've actually done a video already on being able to use the 2515C flyback on the 2501 and vice versa and having no problems. So we will be able to get the 2515C up and going using one of the two 2501 remote boards. And of course, this is the one with the missing top of the pot. We might be able to replace that. Should be able to anyway, but we can just disconnect these connectors and just plug them in on this one and be able to work the 2515C. So we'll start, since this one's complete, we'll start with the 2501 here. I'm gonna put the 15C back away. But I actually have two 2501s and a 2515C. Those are the three that we've got there in the wrapping. So we'll start with this one. So let's, I really don't know. The only information I have is that it's not working. So I think what I want to do, I mean, all the caps are original. Absolutely. No one's touched those. What I'd like to do is just hook it up and see if it works. But before we do that, I want to check the HOT. Make sure HOT is not shorted. Make sure, well, I say make sure the fuse is good, but now that I look at it, there is no fuse. So that's kind of a red flag. Let's put a fuse in it. Let's check the HOT. If the HOT checks good and the fuse gets replaced, well, I should say if the HOT actually checks okay, I'm gonna give it a try to power it up and see what it does, because I want to verify the discrepancy of it being, not working before, or it may be working. It may give high voltage but have no net glow. It may give high voltage and have net glow but have no image. So I don't want to chase down a rabbit hole of incorrect troubleshooting if we can power it up and see what it's doing and say, oh, okay, I know what that is, and have it fixed in 10 minutes versus going through and doing a bunch of unnecessary work. So let's just check the HOT, put a fuse in it, and kind of go from there and see where that leads us here. Okay, well, let's get cracking here. Let's grab the meter. And if the HOT test shorted, that'll put the kibosh on our testing here. But let's go ahead and just check it. Obviously, we can do it from the bottom side, but I think for this instance, let's check it from the top side. So we're looking here. We're going to put our negative on the collector, which is the center, and we're going to looking for 0.45 or so voltage drop to the base and the emitter, which are the two outside legs here. So let's touch the base. And yeah, 0.424, and the emitter, 0.424. So HOT is not shorted. Why the fuse is gone? Can't say. So with no shorted HOT, that pretty much means that it should power on. I've never seen a voltage regulator go bad in this thing. These things is usually pretty good. 9 out of 10 times when it won't power on or it's just ticking, you've got the IC101 right here. IC101 is the switch mode power supply chip, and that's what controls and turns on the actual switch mode power supply, or the actual power supply. This is the main controller for it. If it's just ticking and the HOT is not shorted, you're guaranteed pretty much for it to be this chip is bad. Also, if this does nothing, if we turn it on and it does absolutely nothing, no ticking, no signs of life, no activity, no nothing, it's also the IC101's like the likely culprit. So anyway, let's put the fuse in and let's just turn it on and see what happens. Since the HOT is not shorted, I recall fuses being in here. Well, fuse holders anyway. And there's at least a fuse, yeah. Let's make sure it is the correct rating. This says 4 amp fast flow, I think is what this is. And this says 250 volt T4, 4 amp, okay. All right, well, let's get this in here. Someone's been doing some work on that. Oh, good Lord. I shouldn't have done that. I shouldn't have turned this over. Yeah, except for being... yeah, it doesn't look too bad. Everything looks and appears to be factory. Nothing is has been worked on except this fuse holder. Now, why somebody decided to remove the fuse holder, I can't say. It is soldered in there, not very well, but it is soldered in there. So I guess with that being done and HOT reading good, let's just power it up and see what it does. Maybe the problem was on the operator's end, whoever operator error is, they say. All right, so let's grab a tube, get this plugged in and hooked up and turn it on and see what happens. All right, so we're all hooked up. We're on an actual dedicated 2501 tube with 2501 yoke and everything ready for the 2501. It's missing the installation bracket on the back side, but it's good enough for testing and secure. So we have anode, neck, yoke, power, ground, remote, and video, and we're going to be using test pattern generator for this. So we'll turn it on, and it was set to standard. Let's go to medium res. If you didn't know, the 2501 is medium res. So we have to flip to medium res, turn it back on, and let's see if it even powers on. If it does, what it looks like here. So 1, 2, 3. It's dead. It is completely, totally, 100% dead. And I can almost guarantee it's that switch mode power supply chip, IC101. That little guy, oop, can I get down in there? That little guy right there. There we go. Yep, I can almost guarantee that's the issue. Completely, totally, utterly dead. All right, well, let's change that out and see if that makes any difference. And then if it does and it works and operates, then we'll do the reflow and flyback and cap kit and get this bulletproofed and call this one a quick fix here. So let's see if we can get that changed out and what that does for us here. Okay, so in preparation here, we got the iron and the desoldering station up and running, but I do actually have 4 of those ICs on hand. These are the tube. That tube was dirty. I do have 4 of these on hand from my personal stock of parts, but I want to see if I think I saw some of those in this box of parts that they sent here. Okay, flyback, and flyback. I don't know I think these are voltage regulators or something. Fuse holders. I don't know what's in here. More fuse holders. So I think somebody tried to, I think because this was completely dead, I think somebody tried to, they thought it was a fuse problem or fuse holder problem. But nope, that's not the case. Nope, no ICs. So we'll have to use one from the stash, the personal stash, but that's not a problem. But I just realized before we do that, we should probably make sure the fuse is actually good. It looks good. That fuse looks good. Yeah, it's fine. Okay. Yep. completely, totally, utterly dead most of the time. More times than not, it's the IC101. So we'll change it. If it doesn't fix it, then we'll go from there and troubleshoot further. But let's get that one out of here. And just out of curiosity, let's take some readings before. Yeah, let's take some readings before, and then we can take some readings after. So if we go to here, if we go from, let's go 1, 2, 3, 4, 5, 6, 7, 8. So if we go from 2 to 1, nothing considerable. 2 to 3, nothing considerable. 3 to 4. Well, there's a diode drop there, and there's a diode drop there, and there's a diode drop there, but nothing on that one. So we got diode drop, diode drop, diode. I'm using the 2 center pins as the negative. So 1, 2, 3 to 4 is a diode. 6 to 5 is a diode. 7 to 8 is a diode. But 2 to 1 is not. Now I don't know if it's supposed to be, but let's get the new one installed and see if it's a different reading or not. And it may not be that. Like I say, it's most of the time it is when you have a dead chassis, assuming it's not a broken solder joint or something else. But everything looks fine. Everything looks okay, so let's just go ahead and get this out of here. So the Neotecs are actually notorious for this particular issue of these things going bad. And just like that, it fell right out. So, all right, I'll set this aside. Then we'll grab a brand new one. And then we'll set this one aside. In case it's not that, we can put the original one back in. Alright, so now we need to get this guy in here. There we go. Well, of course, make sure you line the notch up with the silkscreen. Now there's a little hole there where pin number 1 is right there, so it lines up with the notch in the silkscreen. So that's the correct way, orientation. And let's get it soldered in. I gotta hold it in place here while we tack it in. Just tack it in. Give it a little tack. Tack, tack, tackaroo. Alright, so there we go. Oop. Soldered in nice and good, no bridges, everything is nice and shiny. Should be good to go. So now let's test again and see if we get the same readings or something different. Alright, so let's start with 2 to 1. Yeah, same reading. Okay, so no diode there, but let's do 3 to 4. Ah, see, that's 0.5. Interesting. Now let's see, 6 to 5, 0.7, 7 to 8, 0.6. So we do get a little bit of a different reading here on 3 to 4. Yeah, it's changing because it's, well, yeah, it's hot. It's cooling down. As it cools, it gets higher. So, well, I think after changing this out, let's just go ahead and turn it back on now and see if it's still totally dead. If it is, we'll troubleshoot further. I'll probably do some inspection and reflow and cap kit work. It may be a bad cap. It could, if it's not this chip, it very well could simply be a cap in the power supply section that's out of tolerance. It's keeping it from powering up. It very well could be that issue as well. So let's try it again. If it's still dead, then we can do the cap kit, the reflow, and try again after that and see if it's still dead after that. And if it is, then we'll go from there. So we'll get this back on the tube and try it again. Actually, I made a discovery here. That's why this is the amateur channel, because I forget things like this all the time. So as I was getting ready to, I grabbed the picture tube and set it up here on the test bench, and as I was setting it up, I was thinking, oh, wait a minute. I wonder if the B+ pot is bad, because I've had issues before where the B+ pot was bad on the 7400, 7500 series of chassis, where it was keeping it from powering on because the B+ pot was bad. And so I thought, well, let me look at the B+ pot. And if we look at it, it's right here, R112. Now, it's not broken, it's not bad, but somebody has it completely, totally maxed out. Look at that. Look at it. It's all the way up. I can't, if I try and turn to the right, no, it's maxed out. Somebody has gone tweaking on pots here without knowing what they're doing. And so let's wipe this back and forth a bunch of times and set this back to the center. Now, if this works now, I'll probably just leave it the way that it is, because it's likely, I think this chip still might have been bad, but it could also be good. Focus, you rascal, there we go. This could still be good, but I think what I'll do is I'll put a question mark on it, so the next time we have to do some troubleshooting, we'll test it. But we know that one's good because it's brand new, so if it works right now, we'll just leave it the way that it is, and then we'll do the rework and see what we get. But I'll bet you it probably is someone had tweaked this pot all the way up. Now, why they would do that if it was working, I can't say. Maybe the chip was bad and someone was trying to tweak the B+ pot and change the fuse holder and whatnot, but I don't know. Let's see what happens now and with powering it up with the B+ pot not maxed out. I glossed over that on my initial inspection. I don't know why I did that, but anyway, so let's test it now with that in the correct location. Well, in the interest of moving forward as quickly as possible, I tested this again and it's still dead. Completely dead, no signs of life, nothing. So it's getting a bit perplexing and intriguing because I've never seen the voltage regulator go bad. We can test that, but so we know it's not the HOT. We tested that. We replaced the switch mode power supply chip. We verified the B+ pot is not maxed out. I can't say if it's good or not. But it looks okay and intact, and we wiped it back and forth and set it to the center, so it should be relatively good. I guess the next step is to check, I guess maybe, power comes in here and goes through this side of the board. This is the power section. I don't know how to isolate the B+ to the rest of the chassis like on the other ones that I've worked on. I haven't researched it, or I don't think anyone's ever done it. I think it's R119, because actually, no, it's R117, because right here, the B+ test point is right here at R117, right there. R117 is this guy right here, and right here on this, man, that tube is filthy. I'm nasty. Right here is the test point for your B+. So I wonder if we could lift this leg out of the circuit, take this resistor and lift the leg out and isolate the power supply from the rest of the chassis. Usually they've got a line across here that will show you, but I don't know. I'm hesitant to do that. I don't know what that would do. I mean, it can't get any worse. I mean, it's dead already, but so I think let's test the voltage regulator and look for broken joints, which I've already pretty much done that. I didn't see any. We can test the bridge rectifier and this resistor here. We know the fuse is okay. So this is the, for those of you curious, this right here is the built-in isolation transformer. So the Neotecs don't require an isolation transformer because they have one built in, and that's this guy right here. So yeah, a lot of these newer ones have them built in, so you can use it on any type of setup. But let's test our bridge rectifier, this guy right here that converts the AC to DC. And of course, we should be reading a diode across them. So if we go, let's see, this should be a diode here. Yep, 0.5, and then this should be a diode here. Other way. There we go, 0.5. So rectifier is good. Our voltage regulator is right here. We should read, I think, 0.5. Yeah, the other side should be 1 point something or other. Yeah, 1.2. So yeah, let's look for, unless it's a bad cap, bad solder joint, or faulty flyback. And usually when the flyback fails, the internal windings, you'll take out a fuse or any other component, it'll go out in glorious fashion. It won't just die. So I'm leaning more towards a bad cap in the power supply section. Usually it's the IC101. If it's ticking and it's not the HOT, it's IC1. Or if it's dead completely, it's IC101. But this is the first time I think I've encountered one of these where it was totally dead and it wasn't IC101. Since we have to cap it and put a flyback in it anyway, I'm tempted to just put the cap kit in and not do the flyback until we test it after the cap kit. But I'm tempted to just do the full cap kit and do the full reflow, but leave the flyback in and then turn it on and see if it works. If it doesn't, then we'll replace the flyback and see if it works at that point. But I'm half tempted here to just go ahead and do the full cap kit and reflow and see if that brings this back to life. Let's fix this real quick. That's pretty bad. That's better. Yeah, I didn't see any broken or cracked or anything right off the bat like, oh, there's our problem kind of thing. All of this factory solder looks pretty good. So, you know, I'm sure it has to be a bad cap in the power supply section. This is your power supply section, and then it's isolated. That's why there's a big gap here with the rest of the chassis. That's what this all indicates here. This is power supply and regular. So it's possibly a bad cap in the power supply section here. There's a number of caps, not the filter cap. It's never bad, but yeah. So let's just do the cap kit and the reflow, and then give it another try, because right now it's totally dead, and all of the normal causes and issues that generate that have already been looked at. So yeah, it's not the IC101, B plus pot, fuse, bridge rectifier, HOT, voltage regulator. That's all good. So let's just do the cap kit and see what we get after that. Well, a little bit of change of plans here. I got all the caps changed out in the power supply section, and I want to try my theory, because I talked about R117, and that's the test point for your B+. And if we actually follow the pathway here, R117 is right here. Let's get this is R117. And if you see here, this is the output that runs along here and goes straight to, across this cap to the flyback. Now, that is the only thing that connects the power supply side to the rest of the board. The only thing is R117. That's it. That's the only thing that connects the two sides. So if we take R117 out, I've already done it, take it out of the connection here, out of the pad, there's nothing else that connects the power supply side to the main side of the board. This leg here is a ground. This comes off and goes through across here to the main ground plane. So the leg coming off the transformer here, this is a ground. And if you look here, there's nothing else. All through here is separated. This is a ground trace here. This is the wire off, the trace off 117, and that's it. So taking 117 out of here would isolate the power supply from the rest of the chassis. Absolutely 100% for sure. So after replacing all of the caps in the power supply section and lifting this leg out of 117, I'm going to try the light bulb test. I got nothing to lose. So if our light bulb does not light up, we know our problem is a power supply side. If the light bulb does light up, then we know it's a problem with this side, and that will help us troubleshoot immensely. So let's grab the light bulb and a couple of leads. All right, let's plug in the power. Okay, so let's hook up our lead to R117, and let's hook up our lead to, let's just go to the heatsink for the voltage regulator. I can refer to the voltage regulator as vertical IC almost every time. So now the idea is to turn the chassis on. Actually, you know what? We don't even need, it's been a long day. We don't even need the -1, sorry. We can just touch it like that. So we're going to turn it on. We're going to touch this to the ground frame here of the voltage regulator and touch the center here. If our light bulb lights up, then our power supply section is good. So that's what we're hoping to see here. All right, never before seen, never before tested. Let's see what happens. I should have my safety glasses on. 1, 2, 3. Okay, nothing's happened so far. Let's see what we get. 1, 2, 3. Nothing. N-O-T-H-I-N-G, nothing. Do we even have a reading on this? Something is very wrong here. Wow. All right, so we're on volts DC. If we touch our frame and 117, 6 volts. Wow, okay. Something is very wrong. We get nothing on the pot. Wow. 6 volts. Huh. Let's go to AC. So yeah, there's half the phase, half the phase. Okay, so we got AC coming in. You know what I'm gonna do? So our problem is absolutely now a power supply section problem. If we go back to, let's flip these around here. If we go back to R117, $8 volts. Okay, so I was just wanted to make sure we don't have our B plus on this side of the resistor, and not this side, because if we have it on this side, not this side, the resistor's bad. But we only have 8 volts on the B plus. Why? That's going to be the question. Well, I mean, we could throw a voltage regulator in it. I don't think that's the problem, but we can try that. Let's test all the resistors and passive components and things in the circuit first. There's not too many of them. I wonder if we can find any type of B plus energization. Yeah, there's nothing on any of this stuff. Huh. What is going on here? So we have AC. Yeah. Are we getting DC? That's 60. Well, now wait a minute. We have AC going into the rectifier, but we don't have anything coming out of it. Is our rectifier bad? I would say no, because if the rectifier was bad, the fuse would be going out. Something is very odd. Let me do some poking around and see what I can figure out on this, and I'll come back and explain what I found. Well, in the immortal words of Corey Hart, you can never give up, you can never surrender. So I went out and printed the actual complete circuit for the power supply section, you know, this section here that I was talking about, and going through component by component by component by component, I found the problem. So basically R106 is this guy right here, and it resides in this location over yonder. R106 is right there, and you can see from this one that it had the glue on it and everything from, it was around this way, had the glue on it, but it is has basically just disintegrated. This all was intact until I removed it, and as soon as I touched it, and it was so brittle that it just fell apart. And if we actually measure it, if we get our meter here, and measure it. Let's make sure our leads are good. Yep. And if we, let's do it this way. Touch the soldered exposed part of that leg, and this one we get nothing. Wide open. Zip. Zilch. Zero. Nothing. So I have over in the parts pile stash a 2515C parts chassis, and I robbed that R106 off of this parts chassis and put it in here. So this is a replacement R106, and it's supposed to read 820K, but that's out of circuit. In circuit it's somewhere around 134K or something. But when I went through, I found this because I was reading 1.4 mega ohm in circuit across the leads for R106. I was reading 1.4 mega ohm, and when after replacing it with a good R106, now we read 20K, and it'll climb up. 28, 29, 30, 32. So yeah, this was reading 1.4 mega in circuit, and now circuit is completely open. So our problem, I'm assuming, was an open R106. I've never seen that before. You could have knocked me over with a feather. Almost every time you have a dead one of these series of chassis, it's almost always the U101. But in this case, that's not how it was. Not how it played out. So now we should be able to test our hypothesis here. So let's zoom back out. We don't need the meter anymore. I'm not concerned about what the B plus reads. So we're still plugged in. So now we should be able to hook this up and touch this, and then touch our light bulb and have it light up. Now, the reason I say that was I was just hypothesizing about lifting R117 out and having it work like we do for the 7400, 7500, 2000, 5000. For doing that series of chassis for this light bulb test that I've made videos on to test the power supply section, I was just theorizing or hypothesizing that you could lift R117 out and accomplish the same task, because I've never seen anybody document how to do that on this series of chassis, the Neotecs. And looking at the actual schematic here, you can see that R117, there's both sides of 117. This side is the output of 125B plus to the rest of the chassis. So by lifting this leg out, and we should isolate the output of the power supply, and we should be able to do our light bulb test. So now that we've replaced that open R106, let's see if this works. All right, so let's turn it on. 1, 2, 3. Ah, I heard a tick. And if we touch our frame and then touch our light bulb, ta-da! Awesome. Outstanding. Now let's dissipate it. It's going to be a spark here. There we go. Well, what do you know? Imagine that. A faulty open resistor. Well, we knew it was a power supply section because it was dead. I mean, if I was to lift 117 out and got no light bulb, we know the problem is here. So it was just a matter of going component by component per the schematic and testing them. And when I found, when I got to R106, it was open. So there you go. All right, now what we need to do is put R117 back in circuit. Like, get in there, you rascal. There we go. All right. Okay, so with R117 back in circuit, and all of our, get that out of the way. All right, so now with 117 back in circuit, and we have our power supply section recapped, I'm going to finish the cap kit and redo the rest of the caps. And then, well, do I want to do that? Yeah, I have to recap it and change the flyback anyway, because the customer or the client wants that done. So I'm going to just do the rest of the cap kit, change the flyback out, do the full reflow, and then we'll do some testing, because I'm 100% confident now. Oh, these are loose because I removed the neck board and the remote board to keep them from getting damaged from flipping the chassis around. I'll do all the rework and then we'll do some testing because I'm 100% confident that it will work now because we have discovered the problem in the power supply section. So at least it should work and power up. Redoing all of the work here, I'm hoping to have it turn on and be without issue. So if you run into any issues on the backside after doing all the work and getting it operational and up and running, we'll troubleshoot that or deal with that as that happens, if something like that happens. But for now, I'm confident that it should be okay. So I'm gonna do the rest of the work and we'll turn it on and see what it looks like. Well, there we go, all done. Full cap kit, full reflow, new flyback, full inspection. Didn't notice anything else out of the ordinary except for one thing, and I will show that here in a moment. But I got everything wired in and hooked up and cable managed and ready to go. So the only real thing that I noticed while doing this was this capacitor right here. This 35 volt 2200. The one I took out, I've never seen a cap in that condition ever in all these years. Let me show you this cap. My Lord. Oh, so this is the cap I took out of this chassis here. And it looks pretty haggard on the top, but when you look at it from the side, it's all bubbly. The whole thing feels like gravel under there. The whole case is bubbly and just, I've never seen anything like that before. You can see that it's all bulging out all around it. It's hard to describe. You can look right there and see how it's got a curve to it. The whole exterior of this is just the whole thing is just bubbling out like it's ready to explode. And if we look at the bottom side, holy cow, I've never seen something that, look at this, holy cow. This is all that brown glue. This isn't leaking out from the cap, this is that glue. But all this stuff, holy cow. All of this is electrolyte. This is all leaking out electrolyte, and it's leaked out and it's gotten stuck underneath the wrap here, the coating on the outside of this. It's gone underneath here and moved upward, and all of this junk here, look at this. This is all this pitting and this intrusion into the coating here is all electrolyte. This is insane. I've never seen that before. So it's a good thing we didn't power it up, because who knows what would have happened with this like this. So crazy. All the other caps were somewhat okay. I didn't see anything like this at all on any of the other ones. So I want to save that as a souvenir. I got the old flyback removed. I'm sure it's probably fine, but we'll set it aside. Actually, no, it's not. It's cracked. I just now got around to looking at it. It's cracked. Look at that. Right there and right here. Yeah. Okay, well, good thing we changed it. Well, only thing left now is to test it. With everything that was done, we found that bad resistor that was keeping it from powering up, and then after that, changing that out, we got our light bulb to light up, so our power supply should be good. Our power supply section, so at least it should power up now. And after all of the rework and everything, hopefully it works. I'm concerned we may have more problems with how bad that cap was corroded. I'm hoping we don't have any vertical issues, because it's tied directly into the vertical IC right there. But yeah, I'm hoping that it at least powers up, and I've got the B+ set to exactly center, so we should be able to adjust it accordingly. We went to 125 volts. We went 125 when measured right here at R117. So we can adjust our B+ to that. I've got the horizontal hold, which is right here, and the horizontal position. Those are set to center. We can adjust those as needed. I got all the color pots on the drive and bias pots are all set to center, so we can get a good baseline on that and adjust those as needed. So, and this one broken pot, the pot's actually intact, and it should operate. It's just missing the knob, so we should be able to still move it. We don't need the knob to do that. So that being said, let's get it on a tube and get set up to read our B+. Hopefully it turns on and make some adjustments and see how it looks. Okay, hooked up again for round 2 of testing after getting everything figured out and fixed, and we are ready to go. I've got the anode neck yoke ground power video remote, all the critical 7 hooked up. We have our meter set up on our R117 right there to test our B+, make sure we're able to adjust it if we need to. We have our test pattern generator hooked up and we are on and ready to go. So let's give it a test here. Hopefully it turns on and works, and if it does, what kind of image we get, hopefully it's good and we'll be able to adjust and make it look fairly decent. So here we go. 1, 2, 3. Holy shit. Wow. 155 volts on the B+. That's not good. It did turn on though, but 155, oh, yikes. Let's try and turn that down. I'm going to take my driver here and see if I can tweak that a bit. I don't know which way to go. Right, now this is in the way here. Let's go like that. Okay. Let's see, which way do I want to go here? Let's go that way slightly. All right, let's turn it back on here. Hey, look at that, 124. Perfect. What do we get? Anything? Oh, I got to turn this back on. Anything? Please? No, nothing yet. Could be too dim. Oh, it just went into shutdown. Let's turn it back on. Does it go right into shutdown? No, 124.2. We still have no image. And it just clicked off into shutdown. Well, interesting. Let me play around with some settings and see what I can figure out. Well, I have fiddled with this for about 10 minutes and I got the B+ set exactly to 125. I turned the flyback up a bit more and it's operating and running, except it looks like this. I'm kind of at a loss because I knew that it wouldn't be that easy as just an open resistor. With that, as bad as that cap was and the leaking that it did, I was very skeptical of this just turning on and working, and absolutely my suspicions were confirmed because this is the best image I can get after about 10 minutes of fiddling with it. Contrast has no control. Brightness has almost no control. I have no blue, I have no green, it's scrambled. I can get the image to lock on. It's locked on right now, but it looks like this. And the reason it was going into shutdown was because the horizontal hold was off. The pot was too far to the left, and when these Neotecs get hold off that far, and it starts to go into it goes into shutdown because of the hold. If you have your horizontal or vertical hold adjusted too far one way or the other, it goes into shutdown. So that was the cause of shutdown. So B+ is a spot on 125. I got the holds adjusted, everything is working now, but it looks like this. So I assumed something, it wouldn't be that easy. I assumed something was probably wrong, especially with the condition of that cap, and sure enough, it looks like this. So I'm going to have to do some more troubleshooting and more poking around. I want to swap the neck board from the original chassis that was on this tube was 100% operational, so I want to swap the neck board from that one onto here and see if it makes any difference, because I suspect there may be an issue with the neck board. I mean, I have no blue and no green, so I want to rule the neck board out as a possibility, and then I don't know what's going on with this. This could be something on the chassis, it could be off the input of the EGA. Who knows? So a lot more troubleshooting is going to be needed for this. If I find anything, I will show it. Otherwise, yeah, stand by. I'll see what I can figure out, and we'll see how it turns out. Okay, so I successfully got a neck board installed off of a known good working chassis. This is the original one that came with this chassis, and as you can see, it's now much better. We don't have any of the interference or the overly red image. We have all of our colors, red, green, blue, so there's definitely something wrong with this neck board. I'm pretty sure it's the RGB encoder chip. But as you can see, it looks like we have a resolution problem still. So I'm kind of baffled as to what's going on here, because this is absolutely a 2501, which is medium res. However, it looks like it's not. This is a classic symptom of having a incorrect resolution, like putting a medium res board on a standard res chassis and vice versa. So I'm a little bit taken aback here as to what this could be, as to why it's got the wrong resolution on here. Now, let me see if we can perform a little experiment here. Okay, I have a standard res MK1 here. Let's turn this off, disconnect this, set this aside, and just out of curiosity's sake, let's plug in the MK1 board and see what that looks like. Okay, now here we go. Well, see, that's very interesting. See how it's unbelievably too wide, and it's folded over on itself. It's gone over and then folded back around this way. So this should be over here. It's folded, it's way too wide and folded over on itself, but it's not out of resolution. Like, what in tarnation's going on here? Yeah, something is, I'll have to go back and look over my work to make sure I didn't do anything wrong. I don't think so, but so far we have a bad neck board, something wrong with that, and we had the bad was it 106 was bad. So bad R106, bad neck board. We'll figure out what's going on with that. And then also something else is going on here with this resolution problem. So yeah, it's not, I don't know. I need to go back and look and see if maybe there's something else going on here. So the continuation of the troubleshooting shall commence. Okay, so I have discovered the issue with the neck board. This is the original neck board that we had installed on the chassis that was giving us the all red screen and the bad image. And we know that it wasn't an issue with the main chassis that was causing that, because we slaved on that replacement neck board and it fixed the issue of the overly red screen and the bad picture. But now we have to deal with trying to troubleshoot why we have what looks like a resolution problem, and we'll deal with that next. But I made a big mistake with this neck board. The two things now I completely overlooked when working on this. Originally the B plus pot was cranked up. I missed that. Fortunately it didn't affect anything because we had a bad resistor, that R106. The R106 resistor was bad, so fortunately it didn't even matter that the B plus pot was cranked because we weren't getting any B plus output anyway. So that was overlook number one. Overlook number two on this thing was that R948 here was completely missing. If you go back and look at the earlier footage, you'll see that R948 was completely gone out of the neck board. So what I did was, I thought the RGB chip was bad, so I took this one off, I put a socket in and put a replacement on. It made no difference. So I put the original one back on and started looking over the neck board a bit better, and then I noticed that R948 was completely gone. I'm like, what in the world? So I put the resistor on, and lo and behold, it didn't make any difference. So I started chasing through various things, and I took the red transistor out, and it made no... I took the red transistor out, and I actually lost all of the red. The red went away, so I thought, okay, the transistor's shorted. Well, it wasn't. I checked it, and it was not shorted. So I checked Q902 here, that comes off the transistor, and the transistor was shorted. Was it 902? Yes, these two. So R903, I'm sorry, Q. This is very frustrating. Q903 and Q902. Both of these transistors here were shorted. As a matter of fact, I think I have them sitting over here. Yeah, 1 and 2. So, so these two transistors were bad, shorted. Q902 and Q903, both of them are shorted. So this resistor being out of circuit and running on for who knows how long, someone I think robbed this for something else, I can't say, and then ended up screwing me over on the back end here. But so with this resistor being out, it shorted out these two transistors. So after changing out these two transistors and adding in another resistor from, I got, which neck board did I steal this from? I've got this one. I stole it from this one. I have actually two spare neck boards here that I got sitting on parts, but in the parts pile. So I stole a resistor from there, and I stole these two transistors from there. After all that, I'm fairly confident that it should work. So let's get this turned back on and tested again to see if that works, which I'm sure that it will. But now we have to also figure out what's causing that resolution issue, or what appears to be a resolution issue. So that should be the issue with the neck board. I'm confident that it is, so I'm going to turn it back on, make sure that it works now with this original neck board, and then kind of proceed from that point with trying to figure out the resolution problem. So let's see what I can figure out with that. Well, check it out. Got it fixed, but not without much head scratching and gnashing of teeth. I spent about 2 days worth of time trying to get this thing figured out because I wanted to get this done. I didn't want to call it quits. I haven't had a chassis defeat me yet, so I wanted to give this my all and not give up on it, and I was able to get it figured out. So basically there is a capacitor here. It's I call them poly caps. It's not a film cap. These ones like this. Now let's zoom in here. These ones like this are film caps, and I refer to these as poly caps. But basically C406 right here, this guy right here, this is my spare working chassis that I had on this tube that we're testing. So this is a working one off the off this tube. But I'm sorry, C406, this guy right here comes off pin 8 of the LA, I think it's 7851. The 7851 chip off pin 8 goes right through this C406, and you can see this green wire here goes over to the rest of the circuit, and that's for your resolution, your 15 kilohertz or 25 kilohertz for like 2500 versus 2501. With this being a 2501, this chassis here versus 2500, the 2500 doesn't have this yellow wire, I'm sorry, this green wire here. I'm still frazzled that it's working now. This green wire here coming off of one of the legs of C406 here. So how I found this was going through the actual diagram and the schematic of the chip and the chassis. And so C406 is directly responsible for, not responsible for, but it's part of the oscillation for the horizontal. And this is the difference between, one of the main differences between 15 kilohertz standard and 25 kilohertz medium. For the 25 kilohertz medium, I think it's a rating of 562, and for the standard it's a rating of 560. I'll show you the schematic here at the end in a little bit more detail so you understand what I'm talking about. But after going through and testing capacitors and various different things, I started shotgunning in parts based off the schematic. And when I shotgunned in C406, I was pleasantly surprised to see that I was able to get it to work. So we had a bad C406. So with this operational and working now, the repair is complete. So let me get the schematic opened up, and I'll cut to the screen capture, and we'll show and talk about the exact issues that were causing this triple image, unable to sync kind of thing. So the problem, it was syncing. I didn't have a horizontal or vertical sync problem. I had a resolution problem. And the resolution problem was because that C406 on the output of the oscillation from the chip was faulty. So it won't do me any good to show it to you. Well, I'm holding it here in my hand. This is the bad one. It won't really do me any good to put it on a meter or anything because it just reads open. But they're all going to read open. These polycaps, you really can't get a decent ohm reading out of it, and ohms is the wrong way to read it anyway. I don't have a device to test these, but basically, yeah, this is the bad C406. And after slaving one in that from my actual donor chassis, I've got a donor chassis sitting right here that I robbed parts from. So after swapping in a donor C406, we are back in business. So let's get the schematic opened up. I'll show you on the screen capture how I found this. And yeah, we'll chalk this up to a good experience and some good reference if you have this problem in the future. So let's get the schematic opened up, and I'll show you how I figured all this out. Okay, so here we have the actual schematic, and this is for the 2501, and we have the LA 7850. Now I have a 7851 installed in this chassis, but I think the 50 and the 51 for all intents and purposes are basically the same thing. So I don't think it obviously makes that big of a difference. But coming off pin 8 here, you can see here C406. Now if we go to the actual data sheet for the chip, you can see that pin 8, 9, 10, 11, and 12 here are the direct output of the horizontal oscillation circuit. So if we come out of pin 8, you can see it goes right through this capacitor here. They don't have it labeled because it's different, you know, depending on the application of a monitor or a chassis. Yeah, as you can see here, LA 7850 and 51, they're the same thing. So coming off pin 9 goes through a resistor and straight to this capacitor as well through pin 8. Pin 10 is the 12 volt signal, which I had 12.05 volts. 11 goes through the pulse delay, which is another potentiometer, which is part of the, let's see, pin 11. Let's go back here. Pin 11 is, let's see, that goes straight to ground through R419 in the capacitor. I'm not sure what 11 is doing, quite honestly, but not worried about it. Pin 12 goes right to the HOT. So you can see here, this is labeling it as 15 kilohertz, which is standard res. But you notice it says 560 or 5600p. This is labeled different, but let's just say 560. Now, if you go to 2501, it's 562. So somebody out there who knows more about this may be able to chime in. I could be barking up the wrong tree here, but C406 replacing that capacitor fixed my problem here. So I'm not sure if 562 is indicative of 25 kilohertz and 560 is indicative of 15 kilohertz standard res. So 562 must be for 25 kilohertz medium res. That's all I can ascertain. If someone else out there knows more, maybe I'm completely wrong, but that's why this is the amateur channel. I can't say. But all I can tell you is replacing 406 with one from a donor 2501 absolutely fixed the problem. So I knew it wasn't a hold problem, and I knew it wasn't a horizontal hold or vertical hold. I knew it wasn't a hold problem because I was able to get the image to lock on. It was just kind of, it was duplicated and tripled. And so after looking at the diagram here, I thought, well, maybe it's an oscillation circuit problem. And sure enough, coming off pin 8 was that cap. So I changed that cap out and that fixed the issue. So I'm just passing this information along. If you get this same problem in the future where you're adjusting your horizontal hold on there's two holds on this chassis. There's a horizontal frequency pot on the chassis itself. There's also a horizontal hold pot on the remote board. Now you have to kind of use those in tandem with each other. And if you tweak the hold too far to the left, then the chassis will go into shutdown, as we saw earlier. So you kind of have to use the horizontal frequency pot and the horizontal hold pot in unison with each other, combination, to get the frequency to kind of lock on. Now I did that up and down the spectrum, and I could not get this to lock on. After changing 406, I finally able to get it, well, not lock on, I should say, it was locked on. I could not get the frequency to be correct, no matter what I did, until I changed this C406 out, and that solved the problem. So if you have this problem in the future where you've got everything adjusted to where it's locked on, but it has that double, triple image issue, and it's absolutely, you're sure it's the 2501, and you're running a good signal to it from medium resolution, and you can rule out a problem of user error, things like that, then I would throw in another C406, and maybe that'll fix you up. But so that was the fix in this case. So wanted to point that out and share this information. Like I say, it was a big head scratcher, and I'm glad I was able to get it figured out. I did not want this to defeat me. So thanks for watching. I'm glad to pass this information along. Make sure you like, share, and subscribe. I appreciate it. I got 2 more, obviously, as we saw before, to do after this one. So stay tuned and we'll see how well those go. Hopefully a lot easier than this one. So thanks again, and we'll see you on those.